So today we're going to talk about set 12, and the first thing we're going to talk about are symbols of inclusion. And we've already discussed these some, and I've talked to you about what symbols of inclusion are, but let's review this. So I think, what's the one that you think of right off the bat when you think symbols of inclusion? There you go, parentheses. Okay, what about a bracket? Symbol of inclusion?
Yes.
What's the difference between parentheses and brackets? How they're drawn. Yep, how they're drawn. They don't mean anything different, okay? They don't tell us anything differently. It's simply a different way to draw them so that you can tell which ones go together, okay? You could also make like bigger parentheses to help you know that those two go together, right? Masks, okay? There's also the braces, which are harder to draw, but they are the same thing. They are a symbol of inclusion, okay? So when you see stuff inside of them, what do you think about? You got to do that first. That's it, okay? It's a symbol to help us understand that we need to do that first. Yeah?
Wouldn't the division sign also be a symbol of inclusion?
Wait, say that again. Let it louder.
The division sign, when you write a fraction, but it's like...
Yeah, we're going to talk about that. That's good. Okay. So, let me ask you then, with symbols of inclusion, if I saw something like this, okay, parentheses, does this mean do it first? What are these parentheses telling us? Yeah, they're just telling us to multiply. They're not telling us do what's inside of them first. There's nothing inside of them to do, is there? Okay. Now, if you had something like this, now is the parenthesis telling you something to do first?
Yeah.
It is. Because normally, wouldn't we multiply first? Okay, but in this case, we want to do the addition first. We want to go 2 plus negative 3 is negative 1. And then we want to do the multiplication. So for whatever reason, okay, the person who wrote down the problem or this particular problem, we want to do that little bit first, okay? So there's different reasons that happens that we'll discuss as we go along. But that's what we're talking about when we talk about, parentheses first. Parentheses aren't even an operation. They don't even do anything. They just say, okay, in here, let's get this done, and then worry about everything else. Can you think of another symbol of inclusion that we've dealt with? In fact, we did it on was it number 20 that I did from the last chapter? Yeah, I heard it, absolute value. Okay, absolute values, there's a couple things about them. Here, we can't go 5 times negative 6, can we? Okay, we've got to say 5 times the absolute value of negative 6. We've got to do that first, and then we can multiply. So absolute values can kind of have a symbol of inclusion that way. And they also can have something like this going on. See how that's like inside the parenthesis we got to do? Inside the absolute value has to be done. Negative 4. Now what? Come on. Now what?
5 times the value of 4.
Wait, 5 times? Is that the next thing we're going to do?
You have to figure out the absolute value of negative 4.
Okay, the absolute value of negative 4. Okay, now can we do 5 times 4? Now we can do 5 times 4. Okay, and we've been doing problems like this for a few days now, haven't we? Week or two. Okay, so you need to think about, okay, I've got to do that part first. So let's take a look at a problem you're going to run into now. And these aren't horrible, no big deal, okay? And I believe you've done them last year, at least. So you're going to see that in the book, okay? You don't have to write down the original problem. You can do a step. Every time you write something from the book to your paper, you can do a step along the way, okay? So what step do you guys see that we can do right as we first write this thing down. Yeah, inside the parenthesis. Now, when I do what's inside the parenthesis, does that make the parenthesis disappear? No? Like I can't just put, well, that's 5. And let's see, 6 subtract 3, that's 3. So 45 subtract 53. Is that what we're talking about here? Okay, so there's something very important going on, guys. When you do what's inside the parenthesis, that doesn't make the parenthesis disappear. Because that parenthesis is telling you two different things. It's saying, do what's inside me first. And what else is it telling you to do? Yeah, it's telling you to multiply. Without the parentheses, it doesn't say multiply anymore, does it? Okay? So make sure that when you simplify inside the parentheses that you still write it down. Don't be lazy. Then we can go back. So we did what's inside the parentheses, now what? Okay. 20, what's negative 5 times 3? Are you thinking of it that way? You don't just put down that negative sign and then say 5 times 3. Okay? Make sure that you're thinking that way, because let me show you something. If I just put that negative symbol down and then 5 times negative 3, that's negative 15. Well, what's negative 5 times negative 3? It's positive 15, isn't it? Why don't we just skip and get down to the brass tacks here? Let's just do it. 4 times 5 is positive 20. Negative 5 times negative 3 is positive 15. That makes sense? Okay, so over here, negative 5 times 3 is negative 15, and that's just 5. So this is what I would expect to see on your paper. This is in the book. Notice the equal sign each time. Each time we simplify it, we need to say equals this, equals this, equals this. Okay, that's just standard, something we have to do. All right, I want you to do one. Got a little piece of paper there? Anything? You can do this on your notes. You can do it on the paper you're going to do your set on today. Whatever, and I'll walk around and take a look. Don't write down the original problem that I am writing on the board. Do a step when you write it down. You guys are doing a good job. Now the surefire way to miss this problem is to be lazy. Try to do 2 steps at once, okay? Just take it easy, do what's inside the parenthesis, then multiply, then add things up, okay? If you do those 3 steps, okay, you should be fine. So the first thing I would write on my paper would look like this. Now, I wouldn't write the whole thing out like that, but do you understand why I wrote it this way? Okay, I'm just going to do this part. Now, I kind of write it a little bit at a time, so I would say this is -1 plus 5. And then I say subtract 6, and that's 6, and then subtract 3. Okay? If you get rid of the parentheses now, it's not going to work, is it? Okay? Equals. Then I go back to the front. If you find yourself working from right to left and writing the problem back down from right to left, you've got to make yourself stop. You've got to go back to the front, and you got to work from left to right. Okay, that's the way we see the correct signs as we go. Okay, so don't be writing down this from right to left. Don't write down 3 negative and then 36. That will not work. Okay, come back to the front. -3 times 4. -6 times 6. And then subtract 3. Now, these are all negative numbers, aren't they? Right? So I think the answer is going to be negative when I add them up.
Yeah, because there's 3 of them.
Yeah. And I just need to add the 12 and the 36 and the 3, don't I? So let's see. 46, 48, 51. Now, if you missed a sign or something, that doesn't work out, does it? Like if you had a positive here or something like that. Okay? Who did it right? Who knows what they did wrong? Okay, that's also good. Knowing what you did wrong, okay, that's also good. Okay, we're going to try another one. Sometimes it's hard just to write it down correctly from the board to your paper, so. Okay, I just want you guys to do the first step for me. Don't get carried away. Don't go on any farther. Just do the first step here. Make sure you put equals. Come on, Gage. Oh, why did I put 4 minus 2 there? What should I put?
2.
There we go. Okay. Does it look simpler than it did before? Your job is to simplify it, okay? So, there you go. It's simpler, isn't it? Okay? Now, let's look at it now. We've got everything done inside the parentheses. What's the next step?
Simplify and get even farther.
Multiply, right?
Combine exact terms.
Multiply, right?
Yeah.
They're all like terms, okay? Do what's in the parentheses, then multiply, then add. So right here, you guys see that one? Positive or negative? Negative. 2 times 6? 12 times 6? Or how about this? 6 times 6 is 36 times 2. Still work? Sure. Any order you like. What's the opposite of -5? Is that multiplying? We should do that right now. It is multiplying a little bit, and we'll talk about it later, but when you see double negatives like that, the opposite of -5 is +5. We take care of that when we do the multiplication, okay? And then on the end, +3 times 2 is +6. So now we can add them up. -72 plus 5 is -67 plus 6 is -61. Okay. That's as bad as they get. Okay? And really, when you look at what we did, it's not too bad, is it? Do what's in the parentheses, do the multiplication, then add them up. Okay, if you just think of it that way, it's not a big deal. Okay, there's one more symbol of inclusion we haven't discussed. I've talked to you about it previously, but we haven't talked about it today. Ooh, I need to give myself some room here. Let me flip this over. See that big line right there? Symbol of inclusion. A fraction line, a division line. In this case, we're going to say it's a fraction line, and it is a symbol of inclusion. Okay? You've got to simplify the entire numerator down to a single number, and then you've got to simplify the entire denominator to a single number, and then we're going to worry about the fraction line later. Now, why do you think I left myself some room above my problem? Can I work this down the page? I can't, can I? Okay, and so in a case like this, what I'm going to do, well, this would be the first thing I would write on my paper. Negative 3 plus 5. Okay. Plus 7. Negative 5 plus 9. 4. Plus 2. Let's see, and then I'm going to keep going up. 5 times 2. 7 times 4, that's positive 28. Plus 2. And 38 plus 2. Okay, that's 40. Then down, ooh, I should have done the bottom first, the denominator first. Because what if the denominator turns out to be 0? Yeah, we get a quit, don't we? Yeah, but, okay, so the first thing I'd write down is just 4. Subtract 2 is 2. Plus 3, plus 5, what does that give us? What? 10. All right. Now we worry about the fraction, the division, okay? And I'm just going to tell you, we're not trying to divide here. We're just getting a fraction, and we just need to reduce it. 40 over 10, that's just 4 over 1, isn't it? Okay? If the answer comes out to be like 55 over 5, you would just reduce it down and say 11 over 1. If it's 20 over 15, you reduce it down and say, well, that's 4 over 3. That's all I'm looking for. You don't have to change it to a decimal. You don't have to change it to a mixed number, anything like that. Just reduce the fraction once you get the numerator and denominator simplified. Okay, so here's one for you. Give yourself some room on top so you can work the problem, the numerator, up the page. I did the denominator first, and guess what I got? What does that mean? It's undefined. That means there's no answer, right? That means, do we need to work out the numerator?
Nope.
We don't. Now, if you did, that's plus 4, right? You should have got negative 6 plus 4 is 2. Or negative 2, excuse me. But it doesn't matter. Do the denominator first, and if you get 0, you get a quit. Yay! Thomas! You what?
I don't have a question.
Oh, okay. All right. Notice the questions 1, 2, and 3 exactly the same as yesterday. I wonder if that means they're going to be on the test. Just like that. Guaranteed that will be on the test. The guy's like, yes, I can't possibly miss those. It'll be like free 30 points. Is that what you were thinking? I was reading your mind. Okay, let's get going, guys.
When's our next test?
Oh, I'd say Thursday or